In this experiment, we will measure the water flow rate in an open channel. As you know, we can measure the water flow rate in open channel using different techniques. One of the techniques is velocity area method. In this technique, we have to fix a specific portion of the channel. We call that section as channel reach. In that channel reach, the cross-section area should remain similar along the channel. Similarly, we can say that section as the prismatic channel. Okay. After selection of the cross-sectional area, fixed cross-sectional area, 2 points we have to mark 2 points on the reach. We have to measure the length of this reach. Okay. Then after measuring the length of the reach, we have to check the cross-sectional area of this reach. It should remain similar along the channel reach. Okay, for this experiment, we need a hydraulic fuel, or in the field, we have to consider open channel, and we need some kind of markers, and we also need a scale. We have the scale bar, and to write down the calculations, we have to use a notebook. So these are the basic requirements, and we also need stopwatch to note down the time the water will take to reach from one point to other point. These are the apparatus, these are the instruments we will use in this experiment. So, as you know, we have to measure the velocity. Velocity is simply the speed of the water which it will take to reach from one point to another point. So, velocity we can define as rate of change of displacement. So, the time taken by the water to reach from one location to another location, we have to know that time. We already know the distance between these 2 points. So distance divided by time will give us the velocity. So simply we can say that velocity is represented by V. Velocity is represented by V, and it is the ratio of distance over time. Okay. So distance, we will measure the distance in meter units and time will be in seconds. So for this experiment, we need a marker, a stopwatch, a scale, a floating body, and we need a notebook to write down the calculation. And also we need open channel where we have to measure the discharge. So this technique is known as direct measurement technique, and we call this technique as area velocity method. In this area velocity method, as I said, and I told you, we have to fix a portion of the channel. We call that portion as channel reach. Okay, we have to measure the distance between these 2 points. Let's suppose this is point A and this is point 1 and point 2. For example, the distance between these 2 points is 5 meters. And the time taken by the floating body from point 1 to reach at point 2 is, let's suppose, 15 seconds. Then what will be the velocity of the water flowing through this section? It will be around, distance is 5 meters and time is 15 seconds. So our velocity will be around 1/3 meter per second. Or we can say that 0.33 like this meter per second. So we can estimate, we can calculate the velocity of the water flow using the same technique. For this purpose, we will insert this floating body at point 1 and we have to wait until it will reach at point B, at point 2. So we have to note down the time taken by this floating body to reach from point 1 to point 2, and we will divide the distance with that time. So in this experiment, we usually take readings 3 times. Then we will take the average of 3 readings to get the mean velocity. So as I said, we have to measure the water flow rate in open channel, but we are in the laboratory. In this laboratory, we will measure the flow rate in hydraulic flume. This instrument is known as hydraulic flume. It has a pump. It helps us to regulate the water from upstream side to the downstream side. That side is upstream side, water is coming from there, and water is going towards the downstream side. This section is fixed. We have marked 2 points on this section, on this channel. So from point 1 to point 2, this is our reach, and we have to measure the width of the channel. For this, we have to use some kind of scales. So at point 1 and point 2, we have to take two readings for measuring the channel width. So let's take the reading at point 1. So here the width of the section is around 7 centimeter. 7 centimeter, we have to convert the centimeter into meter. Okay, and again we have to take the reading at point 2. Okay, same. Because this is prismatic channel. In prismatic channel, the cross-sectional area and geometrical parameter of the channel remains same along the section length. So the channel width is around 7 centimeter. We have to write down the width and flow depth. Width is 7 centimeter, and we have to take the hydraulic flow depth. For this, we will use a gauge. Actually, we have to measure the flow depth. We will take two readings. One from the bottom and second at the surface of the water. Then we will subtract to get the flow depth. We will take flow depth at 2 points, at least at 2 points. The first point is our starting point of the read. At this point, we have to take the reading, that depth, and we have to take the surface water depth. Then we will subtract from the surface to the depth, bottom depth, we will gain the flow depth. Again, after taking this depth, we have to measure the water flow depth and section 2. Similarly, we have to take the flow depth from the bottom of the channel, and we have to take the depth at the top surface of the water. Then we have to subtract to get the water depth. It will give us the flow depth. We already have measured width of the channel. So width of channel was 7 centimeter, and depth of the channel is around, it's about 15 centimeter. From here we can get the cross-sectional area flow. Area, because this is rectangular channel, and for rectangular channel we can calculate the area as length into width. Okay, so our one dimension is 7 centimeter and our second dimension is 15 centimeter. 15 multiplied by 7, it will give us the cross-sectional area. Our next step is to measure the flow velocity. For that we have to insert a floating body at point 1, and we have to wait until it will reach at the point 2. So machine will help us to control the body. It will stop the body, so it will not go beyond this point. I will insert this body in the middle of the channel, and when it will reach at point 1, we have to turn on the stopwatch. After reaching point 2, we have to turn on the stop. Then the time taken by the floating body to reach from one point to second point, we will know that time. At least we have to take 3 readings. We have to repeat this procedure for 3 times. So let's start our experiment. I will insert the floating body right at the center of the channel, and we have to, as a precautionary measure, we have to insert this body a little bit further from the point of, like section 1 So I will sit here and I will turn on the stopwatch. After taking the readings from the field or from the hydraulic flume, we have to calculate the discharge, or we call that flow rate. The discharge or flow rate is represented by Q. And the formula for the estimation or calculation of discharge is Q is equal to A into velocity, where A is the area, it should be meter square, and G is the velocity. It will be in meter per second. Okay, this is meter square. So for area, because our section was rectangular, for rectangular section, the cross sectional area is calculated as depth into breadth. Area is D into D. So our depth of flow was 7 centimeters, and width of flow was 15 centimeters. We have to convert these centimeters into meters. So it will become as 0.07 meters, and it will become as 0.15 meter. From here we can calculate the area, cross-sectional area flow. So our area will be depth is 0.07 multiplied with 0.15. So it will give us the value of it is about 0.0105 meters square. Our area is calculated. Now we have to calculate the velocity. As you know, we have taken 3 readings. Our first time taken by the floating body to reach from one point to another point was 3.6 seconds. Second time it took around 3.9 seconds, and third time it took around 3.59 seconds. So these are 3 times. We have to take the average of these 3 times taken by the water. T average Vt is equal to T1 plus T2 plus T3 divided by 3. Okay? Can be calculated as, and the charge is actually represented as Q. Q is equal to area into velocity. We have already calculated our area. So this is our area. Now we have to calculate the velocity. Okay? We already have 3 readings of time. We will take every time by adding these 3 values and by dividing total number of values. So our average time is round about 3.6 plus 3.9 plus 3.59 divided by 3. It gives us a value about 3.69 seconds. So this is our average time. We already know that the distance from section 1 to section 2 was 3 feet. Okay? We have to convert these feet into meters. So after converting this, we got value of 0.915. So our length or displacement is 0.915 meter. Yes, 0.915 meter. So time is 3.9669. Distance is 0.915. So velocity is displacement over time. I will write it average time. Okay. So from here we can get the value of velocity. That will be 0.915 over 3.69. So after calculating, our velocity is 0.248. Velocity is 0.248 meter per second. So this is the velocity. Flow velocity. We can say that average flow velocity. Now we have velocity and we already have calculated cross-sectional area. From these two values we can get the flow rate. Area. Our area is 0.0105. We have to multiply this with the value of velocity, that is 0.248. So by multiplying these two values, our discharge is 2.60 to 10 raised to power 3 cubic meter per second. So this is the flow rate or discharge. Similarly, you can calculate the flow rate or discharge in any channel. Depending upon the geometrical shape, you can calculate the cross-sectional area. And after calculating the cross-sectional area, you just have to measure the velocity. When you have the value of area and velocity, then simply multiply area and velocity, you will get the flow rate. Or simply we can call it the discharge. Thank you.